Hello. In this video, we're not actually doing physics. We're learning math, little algebra, talk about proportional reasoning and different kinds of relationships, and show you a trick or two for how to solve them. So here, we're going to just talk about what it means for things to be proportional in different ways. I've got two equations. They're both linear equations. I have y equals 2x and y equals 1/3 times x. And I've drawn a table showing some of those values. So when x is 1, y is 2, x is 2, y is 4. Hopefully you're good with that. And this would be called a directly proportional relationship because this is just an x over here. And what it means to be directly proportional is if I make x twice as big, then y increases by twice as much. If I make x 3 times as big, then y increases by 3 times as much. I make x 4 times as big, y becomes 4 times as big. And you'll see this will hold for any situation in which we have a linear relationship. 2/3 is 2 times bigger than 1/3. If I make it 3 times as big, I get 3 times 1/3, and so on. So this is what it means for things to be directly proportional. Increasing one variable by a certain factor increases the other by the same factor. That's straightforward. Now, the issue is, in many situations, variables are not directly proportional. In this case, we have some quadratic relationships. There's still a proportional relationship here. It's just not linear. So again, I've made up two random quadratic relationships. And there is another pattern here. When I make x twice as much, y, I get 4 times as much. When I make x 3 times bigger, 1 to 3, y gets 9 times bigger, 2 to 18. When I make it 4 times as much, it gets 16 times bigger. And we'll see that proportion holds true for any quadratic equation. So this is a different equation, but we still get that proportion. Twice of x gives me 4 times y. 3 times x gives me 9 times. So this is what it means to have a quadratically proportional relationship. No matter the equation, these proportions, these patterns, hold true. This is why we like to think in proportions, because it doesn't matter what these numbers are. These could be any sort of constant. This pattern will be the same regardless. So how can we use that? Let's say I have this situation, y equals a x squared, where a is some constant. I can write this as y is proportional to x squared. That's what the symbol means, proportional. When we're thinking proportions, we're not caring about constants, things that don't change, because we saw that the pattern, these don't affect the pattern we care about. All right. And I know, I'm told in this situation, okay, when x is 4, y is 17. And I want to know when x is 6, what is y? Now you could go and figure out what a is and do it that way, but we're going to use proportional reasoning. We're going to say, like we were looking up here, all right, 4 to 6, that's a change of 1.5 times. So when I make x 1.5 times bigger, what should happen to y? If this was linear, it would be 1.5 times bigger, but it's not. We have a quadratic. Y is proportional to x squared. How could we figure that out? Here's what I like to do. I like to think, okay, I'm just going to make everything 1. And this is an old physics joke. Let the speed of light equal 1. And I'm just going to say 1 squared. Well, that's 1. All right, so when x is 1, y is 1. Great. What about when x is 1.5, which is 1.5 times 1? Well, 1.5 squared. Oh God, we need a calculator for this. That's 2.25. All right, so when I made x 1.5 times its original value, y became 2.25 times its original value. All right, great. So now I can say, okay, multiplying this by 1.5 means this is multiplied by 2.25, or the square of 1.5. All right, so let's get our calculator out. 17 times 2.25, 38.25. And there, I figured it out using proportional reasoning. I didn't have to know what this A was. I didn't have to do a lot of complicated math. I just said, okay, this is a square. So if this gets increased, then it happens to be the square of that for the other thing. I should just double check since I'm making a video that 1.25 squared is 2.25. Yes, okay, I can do math. Excellent. All right, let's look at another situation. This is not a quadratic, but we'll be able to use the same reasoning. I picked this as a math example. Inverse cube relationships do not show up a lot in physics, whereas quadratics do. But here we go. If when x is t, and we're going to do variables on this one, if when x is said to be t and y is said to be h, if x is changed to 4t, what is y in terms of h? How does that change? Well, I'm going to look at my equation here, and I can say y is proportional, because a, again, is a constant, to 1 over x cubed. And I'm going to use my strategy. Well, if I went from t to 4t, I made it 4 times as big. Okay, so let's start by just putting in 1. 1 over 1 cubed is 1. All right, what about 1 over 4 times as big? So 1 over 4 cubed. That's 1 over, oh gosh, 16 times 4 is what? 64. All right, so when I change this from 1 to 4, I got a change of 1 to just a 64th of that. So instead of h, I'm going to get 1/64th of h, which is h over 64. All right, and again, this could have been a question with numbers. I could say, x equals 5. What happens when x is 20? And we'd realize, okay, 5, 20, that's 4 times. And I said, this is, I don't know, 100. Well, then it goes to 100 divided by 64. So that's proportional reasoning. That's the math aspect. The physics aspect that you'll run into is first figuring out what are your proportions for the relationship you're looking at in a physics situation.